Welcome to The Explainer. Today, we're completely transforming how you write and, frankly, how you think about code. We're breaking down a massive paradigm shift in Python, which is Object-Oriented Programming, or OOP. Look, if you've ever stared at a massive wall of code and just wanted to pull your hair out, well, you're in the right place. This explainer is going to give you the ultimate tools to take back control. Just picture this. You open up a script, and boom, 10,000 lines of chaotic, entirely uncontrollable functional code. You've got functions calling other functions, variables scattered literally everywhere, and honestly, you completely lose track of what line is doing what. As your software scales up, traditional linear programming, it kind of just turns into this tangled, unmanageable mess. It's a massive pain point for any developer trying to grow an application. And that brings us to a really crucial comparison. You see, functional programming is perfectly fine. Great, actually, for small-scale scripts. But, as we just talked about, it gets incredibly chaotic when things get large. Object-oriented programming, on the flip side, is absolutely our organizational savior here. It's infinitely scalable. Why? Because it operates on this beautiful, almost philosophical concept. It literally mimics the real world. It maps physical reality directly into your syntax. Okay, let's lay out our structured roadmap for mastering all this. We're going to start with the limits of linear code, then move into blueprints, classes, and objects. After that, we'll bring those objects to life, give them some actions and magic methods, reveal a pretty wild core truth about Python where everything is an object, and finally wrap up with inheritance and passing traits down. Let's just dive right in. Section 1. The limits of linear code and why we desperately need a new paradigm. Moving to Section 2. Blueprints, classes, and objects, and how we map reality to syntax. Think about how neatly all this maps out. It really is amazing how direct the translation from a physical entity to Python syntax is. If you take a real-world entity, let's say a generic human or an animal, that becomes your class. The specific characteristics, a name or eye color, those become your attributes, which are basically just variables. And the actual things they can do, the verbs like walking or speaking, those become methods. It's pretty much a direct one-to-one translation of reality right into your code. Let's break that down a bit more. Think of a class as your master blueprint or structural template. It's exactly like a factory mold for a plastic toy or an architectural plan for a human. The class itself doesn't physically exist as a specific person, right? It just strictly defines the structure, the required attributes, and the available methods for creating something that actually will exist later. Which brings us straight to the object. An object is the physical realization that you build from that class blueprint. It holds the specific data and the actions. So if our class is that generic human blueprint we just talked about, the object is a specific person sitting in the room with their own specific name, their own eye color, and their own tone of voice. Section 3. Bringing objects to life, or the construction process. Okay, now the real magic happens with this very specific Python tool, the init method. A lot of people call it the constructor. You can genuinely think of this as the literal birth process for our object. It's a built-in function that gets automatically triggered the exact moment a new object is created. It perfectly initializes its specific state and sets up all its base data right out of the gate. Let's talk about the specific parameters you need to actually build that human object using this constructor. First and foremost, we have self. Now, self is absolutely crucial. It's kind of like the contextual glue that binds the object to its own distinct memory. It's basically telling Python, hey, I am talking about this specific human's data right now. After that, we just feed it the specifics, a name, like Qasim or Junaid, an eye color, and maybe a face expression. And once we feed that constructor our specific data, we create what's called an instance. An instance is simply a specific individual object that has been successfully created or instantiated from a class. So, the moment we pass the name Junaid and the eye color brown into our generic human blueprint, boom, Junaid has officially become a living instance of the human class. Section 4. Actions and magic methods. This is where we give our objects some actual behavior. All right, so our objects are born, but right now, they're kind of just sitting there holding data, doing nothing. To actually give them behavior, we use a method. A method is just a function that is directly bound to a specific class, and it defines the exact actions its objects can perform. If you think about attributes as the nouns and adjectives of your code, methods are definitely the verbs. A human walking, a human eating, or a phone making a call, all of those actions are programmed as methods. Now, if you're a beginner, I guarantee you've run into this next issue. Step 1, you eagerly try to print out your shiny new object to the screen, but instead of seeing your data, Python just spits out this incredibly messy, unreadable memory address, right? We've all been there. Step 2, we solve this beautifully by adding the reper_magic method to our class. That method dictates exactly how the object represents itself as a string. Step 3, you print it again, and suddenly you get a clean, perfectly readable human introduction. It just brings total clarity to your codebase. Section 5, everything is an object. The matrix revealed. Prepare yourselves for this one because here is the ultimate mind-bending revelation straight from the source material. In Python, everything is an object. Literally, every single element you interact with in Python is secretly operating on the exact same blueprint rules we're talking about right now. Seriously, think about it. You've actually been using OOP this whole time. Consider the built-in elements you use every day. Basic text strings, those are actually objects. That's why they magically have built-in methods you can call, like .upper. Integers are objects with specific built-in properties. Lists, dictionaries, they are all instantiated objects. You've been manipulating objects since literally the very first day you wrote a line of Python code. Crazy, right? Section 6. Inheritance, or passing traits down. So, we've reached the climax of object-oriented programming, and this is where we learn how to drastically cut down on repetitive code. Consider this efficiency problem. What happens is two blueprints are almost completely identical. Let's say we have a generic animal blueprint, and we want to make a dog blueprint. Do we really have to manually sit there and type out all the exact same attributes and methods all over again? Thankfully, the answer is absolutely not, and that is thanks to inheritance. Inheritance is this incredibly powerful organizational tool where a new child class automatically takes on or inherits the attributes and methods of an existing parent class. It perfectly mimics how children inherit physical traits from their parents in the real world. Let's think about how this creates a brilliant hierarchy. Step 1, we create a parent class called animal with some basic data. Step 2, we create a child class specifically for a dog, and we link it directly to that animal parent. Step 3, pure magic. The dog automatically inherits the name, the species, and the methods of the animal. It saves us entirely from writing duplicate code. But here's the really cool part. While a child inherits traits, it can also uniquely customize them. Consider how a child might customize its behavior. Our parent animal class has a speak method that just outputs makes a generic sound. But a dog doesn't make a generic sound, right? So in our child dog class, we override that speak method to specifically output barks. The child gets to keep that powerful parent foundation, but it establishes its own distinct identity. Which brings us to our final thought for today. By taking the chaos of thousands of lines of code and mapping it to structured, real-world blueprints, you gain absolute control over your software. So how are you going to blueprint your next big project? Are you going to stay tangled in linear code, or will you embrace the power of objects? Thanks for joining me for this explainer. Now go out there and bring your code to life.